Hello guys, welcome back to most commonly asked coding questions. In this playlist, we're going to discuss coding questions from basics to advanced in 3 languages, C, Java and Python. And we are at Fibonacci series up to nth term. So let's solve it. Yeah. First, you should know what's a Fibonacci series. Fibonacci series is a series which starts with 0 and 1. Those two are a fixed 0 and 1. To calculate the third term, you need to just add the previous two terms. That is, to calculate the third term, you should add first term and second term. So 0 plus 1, that is 1. So this is the third term. And to calculate the fourth term, you should add the previous two. So 1 plus 1, that is 2. And the next term is 2 plus 1, that is 3. And the next term is 3 plus 2, that is 5. And the next term is 5 plus 3, that is 8, and so on. So this is basically a Fibonacci series, and you need to print the Fibonacci series up to nth term. So how to do it? So let's take first this first position as T1 and the second position as T2. T1 and T2 are the both terms, those are fixed. And first you need to calculate the third term, that is, let's take that as next. Right. So how to calculate the next? Obviously the sum of previous both terms, right? So next is equal to T1 plus T2. So by doing this, we can calculate the next term, that is 0 plus 1, that's obviously 1. And after that, if you clearly observe what happens, the T1 and T2 are changed. So T2 becomes T1 and next becomes T2, right? So at this time, what's the next value? This is the next value. Next is T1 plus T2 and so on, this continues. So if you clearly observe, just next value is calculated, that is sum of both previous terms T1 plus T2, and after that we are updating. So first thing is to calculate the next value, and the second thing is to update T1 and T2. So if you clearly observe, T1 is coming to here and T2 is coming to here. So it's very simple. T1 is equal to T2 and T2 is equal to next. Right. If you remember these 2 points, you can easily calculate the Fibonacci series. So let's do coding, how to do that. Let's see the pseudocode. Yeah. Let's take, we want to print n terms, right? So n is a variable, we should print n terms. So let's take a for loop. For I is equal to 1, I less than or equal to n, I plus plus. So we need to print n terms, right? So what if I is equal to, what if the user gave n is equal to 1? So first n is equal to 1 is 0, that is fixed. N is equal to 2 is 0 and 1, those are fixed, no? So let's handle that two cases. If I equal to 1, so in that case just print 0, right? Yeah. If user entered n is equal to 2, we have to print first two numbers. So in that case, I is equal to 1, I is equal to 2. Now this for loop runs 2 times. For I is equal to 1, here 0 is printed, and for I is equal to 2, we have to print 1 now. So let's take another if condition. If I double equal to 2. So in this case, what happens? We should print the second term, that is obviously 1, right? Completed. And after that, here comes the case. Now here from third term onwards, we should calculate the Fibonacci number and we should print that. So for that, what would be the condition? If I is greater than 2. So now we should calculate the next term. Here the first point is we should calculate the next term, and after that we need to update T1 and T2. So let's code it. So first we need to take a variable next. That would be t1 plus t2. Here next term is calculated, and after that what we should do, we should update t1 and t2. So t1 is equal to t2, and after that t2 is equal to next. That's it. Very simple. By following this procedure, you will able to print the n Fibonacci series numbers. So let's do coding in C language. Yeah. First, a user need to give a number, no? Let's take n. N is equal to, let's take 9. And after that, if the value of n is less than 1, so that's not a valid input, no? So let's handle that situation. If n is less than 1, we should print invalid input. Printf invalid. Yeah, and after that we need to write a function for printing the Fibonacci series, right? So else we need to call a Fibonacci function. So let's write the Fibonacci function. Void print fib, that's the function, and that will take an input, that is n. Yeah, here in the else case we need to call the function, right? So print fib of the n, that's it. Here this function is called, and in this print fib function we need to write the logic. So as I discussed, first we need to take two variables. Those are first two terms, 0 and 1. So int t1 is equal to 0 and int t2 is equal to 1. So these two are fixed, and after that we need to take a for loop for int I is equal to 1. So from first term it will be going up to n terms, no, I less than or equal to n and I plus plus. Yeah, in this for loop, first we need to check the condition whether I is equal to 1, right? So if I equal to 1, then what we need to do? We need to print the first term. What's the first term? That is 0, right? Printf %d. %d is the format specifier for printing a integers, numerics, %d, and I'm giving a space, and what I need to print 0, right? That's it. And after that we need to check another condition, I is equal to 2. That means the second term. What's the second term? The second term is 1, right? If I double equal to 2, so in this case printf and %d, and I'm giving a space, and I need to print 1. And here comes the third case. In this third case, the I value is greater than 3. In this case, you need to remember 2 points, calculating the next value and updating the t1 and t2, right? So if I greater than 2, so first you need to calculate the next value. So take a new variable next, int next equal to t1 plus t2. Right. After that, print the next value, printf %d and next. Right. After that, update t1 and t2, right? So t1 is equal to t2 and t2 is equal to next. That's it. The program is completed. So just run the program. Yeah, these are the first 9 Fibonacci series numbers. Yeah. What's the time complexity and space complexity? So if you clearly observe, we have used only one for loop in this, right? So we haven't used any 2 or more for loops, and how many times the for loop is executed? Obviously n times. So obviously the time complexity would be big O of n. Big O of n is the time complexity. And when it comes to space complexity, have we used any new arrays on? No, we haven't used any new extra space. So the space complexity is big O of 1. And there is another approach to solve this problem. We have used a normal approach by following a for loop, and sometimes you can use recursion also. Let me explain that too. Basically what recursion is, a function calling itself is called a recursion, and I not recommend you to solve this problem in recursion. Why? Because by solving in this normal approach by doing for loop, the time complexity is big O of n, but the time complexity for solving the problem in recursion is 2 power n. So whenever the value n is large, then the time complexity would be so much. So this is not recommended, but for the basic examples to know the concept of recursion, it is a basic example to know. Yeah. So for a recursion concept, it has a exit condition. In this case, what's the exit condition? We know that the first term is 0 and the second term is 1, right? So obviously these both terms are the exit conditions. So what we know that Fibonacci of 1 is obviously 0 and Fibonacci of 2, that is 1. So these two cases are the exit conditions. So in a recursion, the first most thing you need to understand is it will have a exit condition, and after that you need to follow a procedure. So for the Fibonacci series, what's the formula? F of n is equal to f of n minus 1 plus f of n minus 2, right? So this is the formula. Let's solve this problem using recursion, and let's take n is equal to 5. So for n is equal to 5, we're gonna solve this problem using recursion. So first, by using formula, we should calculate f of 5, right? So what's the value of f of 5? That is f of 4 plus f of 3, n minus 1 and n minus 2. And to calculate the f of 4, and we are just calling the function itself, and we are calling again f of 3 plus f of 2. Here also the same. For calculating f of 3, we need to print f of 2 plus f of 1. And after that, here also the same. For calculating f of 3, we are calculating f of 2 plus f of 1. So if you observe carefully, we know the exit conditions. What are the exit conditions? We know f of 1 is equal to 0 and we know f of 2 is equal to 1, right? So if you observe carefully, f of 2, f of 1. So what's the value of f of 2? That is 1. F of 1 is 0. By calculating this, what value is f of 3? By adding those two. So f of 3 is obviously 1. Here also the same thing. F of 2, we know the exit condition f of 2 is 1. So 1, f of 2 is 1, and here f of 1, that is 0. And the same thing, f of 4, for calculating f of 4, we have f of 3 value and f of 2 value. So 1 plus 1, that obviously 2. Here also the same thing. F of 3 is equal to f of 2 plus f of 1. 1 plus 0, that is 1. So what's the fifth term? 4 plus 3. So that is 2 plus 1, that is obviously 3. So what's the fifth term? 1, 2, 3, 4, 5, that is 3. So we are correct. So the recursion is followed like this. So function calling itself, right? So if the value of n is large, at that time there are so many function calls. So obviously the time complexity would be 2 power n. So I would not recommend you guys to solve this problem in this recursion process. Yeah, let's see the coding in the normal process in Java and Python also. I have created a solution document also where you can refer in the description, where you can find every problem solution in C, Java and Python detailedly explained. And here we have seen the C language, and for the recursion code, the same thing which is simple. Let's take n, that is 10, and call the function Fibonacci function. And what Fibonacci function will do, if n is less than or equal to 1, return n. We know the two exit conditions, right? N is equal to 0 and n is equal to 1. So in that case, n is equal to 0 means it will return 0, and n is equal to 1 means it will return 1. Other than that, it will return Fibonacci of n minus 1 plus n minus 2. That's it. It is a simple code, but when it comes to time complexity, that is big of 2 power n. For the iterative approach, Python code, same thing. Let's take two variables, t1 and t2, 0 and 1, and for I in range of 1 comma n plus 1. So we are printing the terms from nth term up to nth term, no. So 1 to n, and if I is equal to 1, print 0. Yeah, in this print function there is an option called end. What will that do is, in the value of n, what you will give, that would be printed on the screen. So that's it. I am giving a space here, and after that I is equal to 1, I is equal to 2. In that case, what's the second term? 1. I am printing that. And in the else case, it's a very simple thing. Calculate the next term, that is t1 plus t2, and after that print it and update t1 and t2. It's very simple. So same thing in Java also. I'm giving the recursion code in Python also. Have check it. And after that, Java also the same. Taking a variable n, and after that checking whether the n is less than. If it is less than 1, so print invalid input. And Fibonacci print function, take two variables, t1 is equal to 0 and t2 is equal to 1. And after that, running a for loop for I is equal to 1 and I is less than or equal to n. And the same thing, first condition, if I is equal to 1. In that case, system.out.print 0, and I am giving space here. So you need to print this space also. You should remember that. Otherwise, all the numbers are printed without space and you will be confused. And else if condition, if I is equal to 2. In this case, we need to print 1. And after that, else case. And the same thing, calculate the next value, that is t1 and please t2. And after that, print the next value and don't forget the space. And after that, update t1 and t2. t1 is equal to t2 and t2 is equal to next. That's it. Very simple. And I have given the recursive approach also. Check it. Fibonacci series up to n term is completed. Now Fibonacci number or not. If you know how to print the Fibonacci series, 99% you got the answer. So you need to just concentrate on the 1%. So the prerequisites, this is a Fibonacci series, 0, 1, 1, 2, 3. I have discussed earlier. Two things that you need to memorize. Next is equal to t1 and t1 plus t2, and update t1 and t2. t1 is equal to t2 and t2 is equal to next, right? So Fibonacci number or not. In this case, they will give a number. And let's take the number is num. So what you need to do is, you need to calculate the next term and check whether the next term is equal to the num or not. If it is equal to the num, so it's a Fibonacci number, or else continue the process. So this is very simple. You need to calculate the next term and check whether the number is num or not. That's it. So let's see the pseudocode. So first there are two variables, t1 equal to 0 and t2 equal to 1, and we need to calculate the next value. So next equal to t1 plus t2. And after that, a while loop. While, what's the condition? Next is less than or equal to num, right? There is a num, the user gives it, and we need to check whether the num is Fibonacci number or not. Calculating the next term and checking whether the number is Fibonacci number or not. That's it. If next double equal to num, then what happens? The next variable has equal to the num, so that's obviously a Fibonacci number. Print Fibonacci number. And after that, if it is not a Fibonacci number, then we need to update the next, right? So here we calculated the next value and we need to update t1 and t2. So t1 is equal to t2 and t2 is equal to next, right? And after that, again calculate the next value. Next equal to t1 and plus t2 and follow the same procedure. Here the next value is updated and again check the condition whether next is less than or equal to num, and again check the condition next is double equal to num. Whenever the term next has a value, user given value num, if those both are equal, obviously that's a Fibonacci number and print Fibonacci. So that's it. This is very simple thing. If you understand the Fibonacci series, this can be solved very easily. And let's do coding. Yeah. First user should give a number, right? So int num equal to, let's take 21. And after that, we have to check two conditions. No, we know that the first term is 0 and the second term is 1. So first check those two conditions. If num double equal to 0 or num double equal to 1. So we know that these both are Fibonacci numbers, right? So we should print percentile d is a Fibonacci number. And what should come in the place of percentile d? Obviously num. So num. That's it. And what's the other case? We need to call a Fibonacci function, right? So for that, we need to write a function. So int is Fibonacci a number, is Fibonacci a function, and it takes an integer as an input, that is num. And we know that first there are two variables t1 and t2. So let's initialize them. Int t1 is equal to 0, int t2 is equal to 1, and after that next term is calculated. Int next equal to t1 plus t2, right? And after that a while loop is taken, while, and what's the condition? When should the while loop should be exited? Whenever the next value is less than or equal to num. Up to then only the while loop should be run. Whenever the next value exceeds the num, so we no need to calculate those next terms, no. So exit the loop. While condition next less than or equal to num. Yeah. What condition should we check? If next double equal to num. If this condition is true, just return 1. Return 1. So we got the answer. That's why we are returning 1. So if the next value is not equal to num, so what we need to do? We need to calculate the other next value. So for that, first we need to update t1 and t2. So again, t1 is equal to t2 and t2 is equal to next. And after that, calculate the next term. Next equal to t1 plus t2. It's very simple. T2. Yeah. And after that, again the for loop, again the while loop continues. It will continue up to next less than or equal to num. So we need to calculate the next values up to num. After num, we no need to calculate, right? If the next value exceeds the num, so the while loop is exited, and we didn't got the answer, no. So we need to return 0. Return 0. So that's the function completed. Here, let's come to the main function. Yeah, here else if, and we are calling the function is Fibonacci, and we are passing the input num, right? Yeah. If this is true, then obviously it's a Fibonacci number, no? So print the number as a Fibonacci number, right? It's a Fibonacci number. Again, the else case, if it is not a Fibonacci number, else we should print this is not a Fibonacci number. Don't confuse. This is very easy. First, we are checking for the known values 0 and 1. We can write this if condition in this is fib function also. I am writing in the main function. You can do anything do you want. And here else if case. Okay. And after that else if case. And here we are calling the function and checking whether the given number is Fibonacci or not. If it is true, then we are printing. If it is false, then we are printing it's not a Fibonacci number. This is very easy. And when it comes to time complexity, the time complexity for this function is big O of log n, and the space complexity we haven't used any extra variables and space arrays, no. Obviously big O of 1. Yeah. Let's run the code. 21 is a Fibonacci number. Yeah. Let's see this code in Java and Python also. Yeah. You can see the detailed explanation here. And after that, we have seen C language code. And here the Python also. The same thing. First n is equal to 21, and after that we will be checking two conditions, whether the number is 0 or 1. In that case, just print the number is a Fibonacci number. And else if case, we are calling the function, and here also same function, t1 and t2 are initialized to 0 and 1, and next value is calculated, and while next is less than or equal to num. And what we are doing here, if next is double equal to none, return true. If this condition is not met, simply update t1 and t2 and update the next value, and same continue the loop. Whenever the next value exceeds the num, so this while loop is exited, and the given number is obviously not a Fibonacci number, so return false. And same here also. If this function is false, then obviously it's not a Fibonacci number, so print not a Fibonacci number. That's it. Simple. Here also the same. Java. First take num is equal to 21, check condition num is equal to 0 or num is equal to 1. At that time system.out.println print it is a num is a Fibonacci number. Else if call this function, and here also the same function, int t1 is equal to 0 and t2 is equal to 1. Calculate the next value t1 plus t2, and after that while loop, next is less than or equal to num, and if num we will check condition if next is double equal to num. In that case, we got the answer, so return true. And if it is not if the condition is not correct, so update t1 and t2 and next, and continue the process. If the while loop is exited, then return false. This very simple concept you need to understand. Now Fibonacci series up to nth term and Fibonacci number or not is completed. If you really like my content, do subscribe and follow for regular updates. Thank you.